Have scientists really found the most compelling evidence for life beyond Earth on this exoplanet? That seems to be the leading storyline behind this latest research that has been getting a lot of media attention recently. But is that really the case? This is K2-18b, an exoplanet that orbits around a red dwarf star 124 light-years away in the constellation of the Lion, Leo. It was first spotted with the Kepler Space Telescope in 2015 when it spotted K2-18b passing in front of its host star, causing the light from the star to dip a little. This is called the transit method. The planet's existence was later confirmed with the Spitzer Space Telescope also using the transit method, as well as by watching how the star wobbles due to the planet's gravity, aka the Doppler effect. Since its discovery, scientists have taken a closer look at K2-18b and found that it's just over twice the size of Earth, but with more than 8 times Earth's mass. It completes an orbit around its star every 33 days, which might sound quick, especially when you consider that even Mercury takes 88 days to circle the Sun, but because its star is much smaller and cooler than our Sun, K2-18b still falls within the habitable zone, the region where liquid water could potentially exist, making it an especially intriguing world for astronomers to study. And the latest published findings of this exoplanet are causing a stir in the media and between other researchers in the field. I have been obsessed with this story since I found out about it, and I've dug deeper and deeper, and as I've realized a few interesting things along the way. So if you're confused and skeptical about this space news, or if you just want to learn more about the nitty-gritty details, this is the place for you. I'll take you through my learning journey regarding this new research, share how other experts have reacted to it, provide some context behind the research and the researchers, with a little bit of drama peppered in there as well that I didn't expect to pop up along the way. Let's do this. Now, I first found out about this newly published result in an email from a TV producer who was inviting me onto their show to talk about it with their audience. Now, unfortunately, I couldn't accept the invite because I was on my honeymoon. Well, it was unfortunate for them, not for me. I was having a great time. But despite being on my honeymoon, out of curiosity, I went ahead and read up on the news story while my husband shopped in Akihabara. At the time, the embargo must have just lifted on this research because all I could find about it were 2 articles about this discovery, one by The Times and another by the BBC. And let's just say the vibes of each of these articles was very conflicting. The Times article spoke about how K2-18b could be teeming with life, which definitely made me raise an eyebrow. The BBC article, however, was much more measured, with a title, "Telescope Finds Promising Hints of Life on Distant Planet," and mentions of other interpretations of the data of K2-18b from other authors in the field, not just from this new research. But what annoyed me the most about both of these articles at the time is that they didn't link to the actual research paper they were talking about, which is what I actually wanted to read first. But that's because the paper actually hadn't been published yet. However, thanks to my friends and colleagues in the Space Fam group chat, we found a link to the media release on Eureka Alert, as well as the preprint version of the paper on the archive. So with those 2 things, I got to reading. Now, the paper on a surface level seemed quite measured to me. The abstract and conclusions came across as very reasonable, not over-sensationalized, and very cautious of the detection and the work that needs to be done by other researchers to help give more weight to this detection. Keep in mind, this is an opinion of someone who can understand these papers to a certain degree, since I have a PhD in astrophysics. However, exoplanets are not my niche. So there are definitely nuances I don't pick up on when reading things like the methods, for example. But that's why I also seek out the criticisms from experts in the fields of exoplanets and planetary atmospheres, so I can get a better understanding and interpretation from the scientists who live and breathe exoplanet research. Now, I'll get into what has been said by other experts later in the video, but when I dug deeper into the research behind K2-18b and the context behind this particular research, a few not quite red flags, let's say orange flags popped up for me. Basically, I'm very cautious about this result now that I've gone further than just the articles and the stories from traditional media and delved more into the research regarding K2-18b. So let's get into that so you can be well informed too about this research. Let's start with the stark difference between the tone of the research paper and the tone by the vast majority of the media, including quotes from the lead author in the official press release. Now, despite a select few reasonable media articles, like the BBC one I came across early in my search, the vast majority of popular articles have gone down the route of this is the best evidence yet for life beyond Earth, which is a stretch. The paper, however, paints a very different picture. There are 3 things I want to highlight just within the abstract of the paper, so the top-line summary of the research. Number 1, yes, they say their observations of K2-18b's atmosphere with JWST cannot be explained by any other molecules other than dimethyl sulfide and or dimethyl disulfide with some statistical significance, but not enough for a fully confirmed discovery. Second, they note that these molecules are both potential biosignature gases, so they could potentially be an indicator of alien life. But thirdly, and this is the most important one, they also stress the importance of additional experimental and theoretical research to confirm this discovery, not only as a confirmed detection of these gases alone, but also to confirm whether or not they're actually formed through biological processes, aka by alien life. That is very measured, in my opinion. It highlights their results and the statistical significance of the result and what that means, but it also highlights what needs to be done to confirm or deny this result and the implications of its potential connection to alien life. Contrast that with the response from the media, and it's like night and day. And I think that's partially a result of one particular quote provided by the lead author in the official press release. Now, before I highlight the quote that I think has contributed to this over-sensationalized approach taken by the media, I want to stress that not all of the comments made by the research team are concerning. The quote is, "Given everything we know about this planet, a Haitian world with an ocean that is teeming with life is the scenario that best fits the data we have." If this is all you heard about this result, if this was the only quote you'd come across from the lead author of the study, you'd think we were super close to finding life on another planet. But they're not even saying this with such confidence in their research paper. So I think that this quote is part of the drive of this over-sensationalization of this research in the media. Besides, it isn't even confirmed whether or not K2-18b is actually a Haitian planet or not. Here's what other research teams have proposed about the nature of K2-18b in the past since its discovery in 2015. Number 1, a habitable ocean-covered Haitian world. That's what this team is suggesting in this latest paper, but it goes back to a few years earlier. In 2020, Madhu Sudan and friends suggested that K2-18b could be a water world surrounded by an atmosphere full of hydrogen gas, called a Haitian planet. In fact, Madhu Sudan coined the term in a later paper in 2021. I'll provide you more of my thoughts on that later. But this isn't the only potential explanation, which brings us to number 2, a mini Neptune or a gas dwarf with no solid surface. This is another leading explanation that K2-18b is simply a mini Neptune, a small gas giant with no solid surface and no hope of being habitable. Wogan and friends in 2024 argued that the methane and carbon dioxide seen in the JWST data can be explained by a mini Neptune planet with 100 times the metal content of the Sun, with no need for oceans or life. Their simulations found that lifeless Haitian models didn't fit the data as well as this gas-rich mini Neptune scenario. And it's not just them. Shortall and friends also in 2024 pointed out that K2-18b's bulk density could be consistent with a wide range of interiors, many of which wouldn't support life at all. So in this picture, K2-18b might have a thick atmosphere, swirling clouds, and interesting chemistry, but no oceans, no surface, and no life. The third big idea I want to share is this: a lava-covered world, a magma ocean planet. Again, Shortall and friends in 2024 flagged this as a plausible interpretation based on the planet's interior models. In this scenario, K2-18b might be covered in molten rock with an atmosphere that's partially shaped by silicate vapor rather than water, a far cry from anything habitable. The bottom line is, the jury is still out on K2-18b. On top of the range of explanations presented by different research teams of K2-18b over the years, there are also some very nuanced criticisms made by experts in the field regarding this latest research that I want to discuss. The first is a thread by Dr. Ryan McDonald on Blue Sky. For context, Dr. Ryan McDonald is an exoplanet and astrobiology researcher and currently a NASA Sagan Fellow at the University of Michigan. He has been published on over 78 research papers relating to planetary atmospheres of various exoplanets, garnering over 3,000 citations of the work he has been involved in. So definitely a well-respected expert, in my opinion. He took to social media to explain why he's not convinced, and honestly, his points are pretty important. First off, Dr. McDonald stresses that a biosignature wasn't actually detected, at least not by scientific standards. The team behind the K2-18b study reported what's called a 3 sigma signal for dimethyl sulfide and or dimethyl disulfide. Now, in normal life, 3 sigma sounds impressive. It suggests a 99.7% confidence level, meaning that there's a 0.3% chance the detection is false. But in exoplanet science, especially when you're talking about the possible discovery of life, that's not enough. The gold standard is 5 sigma, which equates to a confidence level of 99.9999%. That's what physicists use when confirming the Higgs boson, for example. Basically, you want to be almost absurdly sure before making a claim this big. And as Ryan puts it, the language in the original paper is key. They refer to a detection of dimethyl sulfide and or dimethyl disulfide. That and or is doing a lot of heavy lifting. The team couldn't even distinguish which molecule it might be, so it's not a clear detection of a single known potential biosignature. Dr. McDonald also raises concerns about the modeling approach. Essentially, the researchers built a model where only dimethyl sulfide or dimethyl disulfide could explain a portion of the observed spectrum. And by narrowing down the options like that, it can make the presence of these molecules seem statistically stronger than it might really be. Ryan refers to this as statistical hacking, a term used for when models are tuned or structured in ways that might exaggerate the significance of a result. It's not necessarily dishonest, but it can lead to overconfidence if you're not careful. To support his case, McDonald points out that when his own team independently reanalyzed previous JWST data of K2-18b, they confirmed the presence of methane, which is interesting on its own, but found no signs of dimethyl sulfide or even carbon dioxide. His third point is where things get especially spicy. Dr. McDonald takes issue with the way the findings were presented to the public. The University of Cambridge, home to the publication's lead author, released a statement claiming the probability of the dimethyl sulfide signal being false was just 0.3%. But Ryan argues that this number comes from a misinterpretation of Bayesian statistics. When you run the numbers properly using what's called the Bayes factor, McDonald says the odds that no dimethyl sulfide or dimethyl disulfide is present could be as high as 27.6%. That's dramatically less convincing. It's actually closer to a 1 sigma result, which in most fields wouldn't even make it to a published paper. He's especially frustrated that this bold claim was broadcast to the public without proper context. In his words, this is bad science, worse science communication, and deeply misleading to the public. Oof. To be fair, the lead author, Dr. Madhusudan, has defended his team's work. He said it's scientifically valuable to report signals, even at lower confidence levels, especially when they come from such cutting-edge data like from JWST. He's also emphasized that the team ran robust tests and independent analyses before publishing. This isn't a case of right versus wrong. It's more about how confident we should be and how that confidence is communicated, especially to the public, especially when it involves things like alien life. Now, NASA and other scientists have also responded with caution. Nobody is denying that K2-18b is an exciting target or that dimethyl sulfide would be a huge deal, but most experts agree we're just not there yet. More data, more checks, and clearer models are still needed. Now, another well-respected voice weighing in on this is Professor Chris Lintott. You might know him as the host of The Sky at Night on the BBC, and he is also an astronomer at the University of Oxford, researching the fields of galaxy formation as well as exoplanets. When someone like Lintott speaks up, people in the astronomy world tend to listen. So let's unpack what he had to say. Now, one thing Professor Lintott is quick to point out is this. The phrase hints of life didn't come from journalists running wild. It came from the press release written by the scientists themselves. And this is kind of a big deal. Usually when science news gets blown out of proportion, researchers will say something like, oh, the media misunderstood us. But in this case, the framing, bold and life-hinting, was set by the team behind the research. And that's raised some eyebrows, including mine. Just like I said earlier in my initial thoughts, Lintott also takes issue with a quote from the lead researcher on the K2-18b study, and his response is pretty blunt. From the calls I've made, I doubt there is an astronomer outside the team who would agree with that. That is a strong statement. What he's saying is that most astronomers aren't on board with jumping to the conclusion that K2-18b might be teeming with life. Lintott also points out that there's independent research that we've discussed earlier, published elsewhere, but not cited in the recent K2-18b paper, that failed to find evidence for dimethyl sulfide entirely. Not only did those teams not find any dimethyl sulfide, but they also cast doubt on whether K2-18b even has an ocean at all. So we're not just dealing with one interpretation here. We may have multiple teams looking at the same planet and reaching very different conclusions. That's a hallmark of an active scientific debate, not a settled discovery. Lintot's point is simple. Let's be excited, but let's not get ahead of ourselves. However, despite this very measured and professional criticism, it seemed that the lead author took it a bit personally and in response to Chris's points said this on live radio.
I mean, this is the difference between a practitioner and a commentator, right? I mean, from a practitioner's point of view, this is the as best as it gets in science, and you just have to recognize it. But for that, you have to be in the field, not outside.
I'm sorry, what? Professor Chris Lintott, professor of astrophysics at Oxford University, who is an author on hundreds of research papers, several of which are regarding exoplanet research, garnering over 28,000 citations, is merely a commentator and not in the field? For good measure, I'll also mention that Professor Nikku Madhusudan, the lead author, is also an author on hundreds of papers and specializing in exoplanet research, garnering over 18,000 citations, so he is definitely an expert in the field. But come on, mate. Calling Professor Chris Lintott merely a commentator and not a practitioner and not an expert in the field was a low blow and completely unnecessary. But this behavior, from the leap between the language used in the paper to that used by Prof. Madhusudan in the press release, and then this snide remark towards Prof. Lintott, it started to make a lot of sense to me as I kept learning about the broader context of this research. Firstly, and I've glossed over this detail already in this video, Prof. Madhusudan coined the term Haitian planet. He and his research team proposed that K2-18b could be a water world with a hydrogen atmosphere in their 2020 paper, and then gave this hypothetical class of exoplanet the name Haitian in their paper in 2021. Secondly, they not only suggested it as a new class of exoplanet, but also as one that had the potential to host life. Makes sense. A planet with lots of water could host life. After all life on Earth, as we know it, requires water to merely exist. So imagine being the lead author of the research team that first proposes a new class of exoplanet and proves their existence, and on top of that, ends up finding definitive evidence for life beyond Earth on an exoplanet that fits into the class of exoplanets that you came up with. That would be a monumental moment. Your name would be remembered alongside names like Galileo, Newton, Einstein, and it would probably earn you a Nobel Prize. When you connect those dots together, this behavior starts to make more sense. And to be fair, going back to my initial thoughts about this whole news story, at first glance, I didn't think much of it. In terms of the leap in the language used in the paper and to that used in the media, yes, the comments in the press release on the lead author are definitely more hyped. Like, this result is exciting, and if you were the lead author, you would probably hype your results too and have pride in you and your team's work. But like I said, things started to unravel a little more when reading criticisms from experts in the field and how the lead author reacted to a few scientists and science communicators very fairly and professionally commenting to the media about this result, which I also did this weekend, so who knows if I'll get a jab or two as well for commenting to the media, let alone making this video. But look, I don't blame them for being excited about their work. It is really great to see so much passion in science research. But do I agree with other scientists like Dr. Ryan McDonald and Prof. Chris Lintott that we as a scientific community need to be careful about how we communicate our science to the public, especially when it comes to big claims like potentially finding signs of alien life? Yes, absolutely. What I hope you take away from this video is that there can be lots of nuance when it comes to scientific research, especially when it's communicated widely to the public. And again, like Dr. McDonald and Prof. Lintott stressed in their criticisms on social media, approach headlines like these claiming hints of life with caution and skepticism. But also, how about we just don't be rude and snarky to people, especially colleagues in the field that are just trying to be measured and bringing a measured lens to the science we're trying to get people interested in, okay? Let's not do that. Although I do love drama, and that interview on BBC Radio was a great replacement of my drama media consumption now that Mass Australia has ended. Anyway, we're getting off track. To finish us off, here's what to expect next. The detection of dimethyl sulfide and/or dimethyl disulfide in the atmosphere of K2-18b is still yet to be confirmed. The research team proposed the following directions to take beyond their current research paper. First, further observations with JWST are planned to help increase the statistical significance of this potential detection. They say that between 16 and 24 more hours of JWST observations may help them reach the 5 sigma detection level. although after reading Dr. McDonald's explanation of his criticisms, I'm still skeptical of whether 5 sigma will be meaningfully 5 sigma in this context, but I digress. On top of this, independent analyses of existing and future data are expected to surface from other research teams looking at K2-18b. This could end up looking a lot like the phosphine on Venus story, or it could confirm the existence of dimethyl sulfide and/or dimethyl disulfide on K2-18b. Either way, independent analyses will likely pop up and add to the conversation. And again, the research team behind this claim also stressed the importance of more theoretical and experimental work to investigate how these molecules can be created without the need for life. They stressed that very clearly in their paper. Not so much in the media, but they did in the paper. But again, the very nature of K2-18b is still under debate. Is it really a Haitian world? Is it simply a mini Neptune? Or could it be a hellish world with lava for an ocean? That's still a big mystery that needs to be unveiled before we can start really entertaining the idea that life definitely does exist on this planet. Because if it isn't a Haitian world, it probably doesn't exist on K2-18b. At the end of the day, this is what makes science exciting. And different teams interpreting the data in different ways is really important, because if all these teams interpret the data in different ways and eventually come to the same conclusions, we will have improved our understanding of the universe as humanity just a little more. And that is awesome. I will be keenly watching this debate unfold, and I'll do my best to keep you updated as new findings come to light. But until next time, stay curious, stay skeptical, and keep looking up.